inequalities, you have to think a little bit more carefully. If this had been an equation, so if this had said x squared equals 9, what would we have done to have solved it? Rihanna?
We square root 9 and x would equal 3.
Oh, what is Karen said? That's not what she said. We'd square root 9 and our answer would be 3. Not quite. Just want a bit more information. Remember that? Because when you square root something, remember at this level we have to remember that the square root of something we get the negative option as well. Baby, you remember that? Yeah. Alright, so we would have two different options. We've got the x is positive 3 or x is negative 3. Okay, now inequalities causes an issue because we wouldn't say that x is greater than 3 or greater than negative 3 because that doesn't make sense. It can't be both of them. Yes? Or if it's greater than negative 3, it's obviously greater than 3. So that's not going to be the answer. So my suggestion to you is that you want to picture the x squared graph. Okay? If I was to picture the x squared graph, we know it does that. Yes? And if I want my value of this graph to be greater than 9, so let's pretend that 9 is here. What value do we have here? What value is this? Negative? Not negative 9, negative 3. Yes, because negative 3 when squared gives me 9. And this value is going to be positive 3. Okay. So, we are talking about x squared being greater than 9. Our graph is greater than 9, all of these places, and all of these places. Are you happy with that? You see, everyone see that? If you're sitting there going, what the heck is she on about? Tell me now. Alright, so if I want my graph to be greater than 9, if this is my value of 9, then these are the parts of the graph that are more than 9, okay, because they're above here. Yes? A little bit better? All of these parts of the graph would be less than 9. So if I was talking about less than 9, I would be talking about green. So less than 9 is green. Oh, that's 9. More than 9 is blue. Okay? So our question says greater than 9. So now we need to look at the x values that are satisfying that. So for our graph to be more than 9, it shoots out over this way, which means that my values of x must be greater than 3. Do you see that? So for my x squared to be greater than 9, my x has to be greater than 3, or x has to be less than negative 3. So your final answer must include both of them. Because my graph, my values of x could be more than 3 or less than negative 3. Here we go. Alright? No? Pause it. Now, it's not part of the question, but I just want to make it clear that sometimes you're asked about less than. Okay? So if it was less than, we're actually talking about, this part of the graph, in other words, this area here. Yeah? Remember, if we're talking about just a little portion, that's when we have the one grouped inequality. So for this green, it would be negative 3. Okay, so if we're talking about this portion here, negative 3 is our smallest number, and that's less than x, which is less than 3. Remember, our x goes in the middle, our variable goes in the middle, and our arrows always point left. So that would be if we were solving less than 9. Okay, so the negative stream, positive stream are the same for both of them, but you have to establish, is it this situation or is it this situation? Now, I cannot say that if you have greater than, that it's always going to look like this. The reason being is, if your quadratic is upside down, then it's not always going to be greater than. It's not always going to have two portions, okay? It would be one of these situations here, all right? So that's why understanding your quadratic graphs, just being able to visualize what does it look like. You don't have to draw it perfectly. You have your calculator. You can plot it in your calculator and have a look, all right? So draw it on the calculator, see what it looks like, have a look, see, are we talking about a situation where you've got two portions, or is it one little range? Are we all right with that? Okay, so when we're talking about quadratic inequalities, it's just a little bit different.